know where we stopped yesterday because we were getting ready to we did our first problem. We're going to go on to example 2, and I didn't get to record anything. So, go figure. So, happy Friday. 2013, holy moly. Here we go. We're still factoring. This is going to go fast, so hang on. If you need me to slow down, you need to be your own self-advocate, and you need to say, whoa, Hoss, slow down, okay? And that's all right. So here we go. So this will be your example 2. 7a squared b cubed c times, nope, yep, nope, that's a lie. That was a test. That was a psych. Sorry. Let's try this. 14a squared b cubed c minus 21a squared b to the 4th c plus 7a squared b cubed c. Sorry. (14a squared b cubed c minus 21a squared b to the 4th c plus 7a squared b cubed c. I'm all about seeing things differently, okay? Half of you may see one way to do this problem, the other half of you may see another way to do the problem, and then there might be 2 of you that see a totally different way to solve this. I'm okay with that. What's the first thing you're supposed to factor out always? Greatest common factor. If you can't factor out a greatest common factor, what else can you do? Does anybody see anything else that you could do with this? Look at it real carefully. Look at the variables real carefully. And don't be afraid to speak up. Come on. Nobody sees. All right, so are we just going to factor out a GCF? Is there a GCF to factor out? Yeah, what is it? 7a squared b cubed c. Okay. All right, so what's that going to leave us? This is factoring out the GCF. What's that going to leave us? 2 minus 3, 3b, plus 1. Anybody see anything going on now? Why? Because they're like terms. Did you see the like terms in the original problem? Did anybody see the like terms in the original problem? You did? Could you have gone that way first and then factored out to GCF? Yes. More than one way to skin a cat, folks. Okay? So what am I going to do? Jansen, what am I going to do with the 2 and the 1? Combine them. 7a squared b cubed c. 2 plus 1 is 3 minus 3b. Oh, snap. What's going to happen now? I mean, if we're simplifying, what do we have to do? Now I've got to take out a 3. When I take out the 3, Beth, what do I have to do with it? I got to multiply it to the GCF, right? So I got 7a squared b cubed c times 3 times, remember this 3 is the GCF of our quantity. 3 times what gives you 3, everybody? 3 times what gives you 3b, everybody? 1b or minus 1b or just plain old 1 minus b. And then what do we have to do? Because we've got to clean it up. Multiply. What's 7a squared b cubed c times 3? 21. A squared b cubed c times 1 minus, I'm going to clean it up, 1 minus b. Is that acceptable? Yep. Pardon me? Yep. This, you need to see it. Okay, middle rows always got this problem. You guys may, especially like from Kayla back, y'all may want to move your desk, move your desk, move your desk. You may have to zigzag because y'all always have trouble seeing. Questions at all? Facile, difficile? Comme ci, comme ça. I see, I see. I see, I see. Yeah? Y'all cool? Y'all know what I just said. Is it easy or difficult? I'm trilingual, and I am learning a fourth language. Happens to be Italian. You got to give me the words, man. You got to give me the easy, difficult words. I'd have forgot them. I didn't learn them, so I forgot them. I'm going to have to write them down. Okay, not right now. Moving on, because I will not be distracted today, Cody King. I will not be distracted. Do you hear me? I don't care how much you plot against me. Here we go. Difference of squares. This is, again, a fake out. It's not example 3. I know. I just want to keep y'all on your toes and just give you more reasons to love me. And all my faults. Many, 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 many. What did we learn about yesterday? Difference of squares, how many terms? 2 terms. Difference means what? Subtraction. And it's going to be the subtraction of 2 what? Come on, come on. The subtraction of 2 what kind of numbers or terms? Perfect squares, attaboy. Subtraction of 2 perfect squares. Guys, I abbreviate everything. All right, you will learn my abbreviations. Some of you already know them. Subtraction of 2 perfect squares. Easy, easy, easy. X squared minus 4. I mean, that's the algebra 1 problem right there. How you going to break that down? Come on now. What is it? I can't hear, literally. X plus 2, X minus 2. Difference of squares are the best ones. You always want to see a quiz or a test full of them because I'm like, yes, I got this. Easy. Right on? How about this one? 9x squared minus 64. Go. And folks, if I get to going too fast and I lose you, remember I am recording this. So you have to go home and do your job. Or when you're not in the cafeteria, not during lunch, not using any Wi-Fi, anything, you can watch the YouTube video. What kind of YouTube video are you watching? Miss Perry's trig lesson. Oh, how do we break this one down? 3x plus 8? 3x minus 8? How many of you had that? Hands up. High five in the air. Boom. All right. How about this one? Y'all a bunch of smarty McFarties, I can tell. Here we go. 25. X squared plus 36. Go. Got this one? What do you think about this one? 5x plus 6? 5x minus 6? How many of you had that? Okay. What's the answer? This is what I'm standing up here looking. Q's doing this. He wrote it and then he went. You wrote minus down? Ah, fart face. What's the answer? Ah, see, light bulb. I just saw a light bulb go. Bing. Go on. Is this a difference of squares? This is a sum of squares. Do we even know how to factor a sum of squares? Have you learned anything about a sum of squares? No. We've learned about sum of cubes, right? What's the answer? That cannot be factored. If you put 5x minus 6 times 5x plus 6, that is not the answer. And I would not erase it. I'd put a big old X through it, and I would write to the side why. Why it's incorrect. It's incorrect. Why? Because it's a plus in the middle. A difference of squares has to be what in the middle? A subtraction. Folks, if it's not factorable, what do we write? Prime. It's prime because of that plus sign. How many of you had prime? There we go. For real, did you really? Yes. Really? Because you were like this. Ugh. You were waiting. He was like fast. All right, I'm going to blow your minds. You ready? I'll make you cry. Seriously, it's going to make you cry. Get ready. I got 2 boxes of tissues. What kind of math class are we in? Advanced, right? Now, if you are a forest person, have y'all ever heard the saying, can't see the forest for the trees? Those of you who I've taught you are there in that problem. How many terms are there? It looks like 4 because you've got x plus 2, which is 2, and then x plus 3, which is 2 more, right? But we have, what's the difference in this problem and one of these? What's the difference? What is it? It was 2 sets of parentheses. We've got 2 quantities, right? All right, so let's change the way we're thinking. Here we have the difference. Would you agree that it's the difference? It's a subtraction symbol. It's the difference of 2 quantities. Do you guys agree with that? Your silence tells me a lot. Thank you. Would you agree that those quantities are what? What do you recognize? They're what? They are adding and subtract. Say it again. They are. They are being subtracted from one another. Yes, that's right. But look at the quantities. If I were to what? They're squared. This is the difference of 2 quantities that are squared. I want you to think about something. Folks, you've got to learn, because I'm going to tell you what, some of this stuff you're going to look at, especially when we get to trig identities, you're going to think, what in the world can a math problem have 45 letters in it, hardly any numbers, and it's called math? You've got to learn how to make connections back to something you are familiar with. Okay, and y'all remember how I connected yesterday? I went, ooh, Easter, Luke, Ale, ooh, yes, Leslie, because that's so stupid, but it works for me. If once you make a connection, check this out. What if this is just a think line, okay? What if I were to change this quantity to just plain old x squared? The quantity into x. Or let's change it to like a k. Let's change it to k so it won't confuse you with the x that's already up there. And then minus, what? And let's change that to m squared. Think. Now if I were to change those quantities to just letters, okay, my quantities were different, so I'm using different letters. Then what is k squared minus m squared? That's just a difference in squares. And how would you factor that? Come on, y'all. How would you factor k squared minus m squared? K minus m and k plus m, right? Okay? Trying to make you figure out how to make a connection. All right, if I can do that, then that's just a think box. Do we have the difference of squares? I've got the difference of squares, except now it's going to be quantities. You're going to have to think on this and ponder, okay? Check this out. I'm going to have two sets of parentheses. How do you figure out what goes in the first spot? Well, you take the square root of that first term. Folks, what's the square root of x plus 2 quantity squared? It's the quantity, x plus 2. So watch, x plus 2, x plus 2. What's going to go in the next two spots? What's going to go there? Say it, I can't hear you. X plus 3. X plus 3. What's going to happen to my signs in the middle? They're going to be different. One's a plus, one's a minus. This is like a difference of squares problem on steroids. Now, what are you going to do within those parentheses? Look at them. What are you going to do? Aren't we just going to combine like terms? Can I do that? If it's plus, can I rewrite x plus 2 plus x plus 3? Can I write that? Yeah, I can write that. Because it's just a quantity plus another quantity. I can do that. Can I do that on the next one, though? Why can I not do it on the next one? Because it's subtraction, okay? Check this out. Remember, I've got to distribute that negative sign, and it's going to become x plus 2 minus x minus 3. All I did was distribute that invisible negative 1 right here. I don't know why the letters are curved. I'm not making them curved. Y'all are still blank stares for the most part. Wow. How do you combine in the first parentheses? Combine like terms, folks. X and x is 2x. 2 plus 3 is 5. Would you agree, yes or no? All right. How about the next one? I got x and minus x, 2 and minus 3. What's going to happen? My x's cancel, and then it's 2 minus 3, which is negative 1. Oh, we're getting back to algebra 1, right? What do I do now? Distribute. We'll distribute backwards. And it's going to give me negative 2x minus 5. What the crap? Look where we started. How about this? Oh, this is a good one. This is another one of those problems that we could see it probably 3 different ways. What's the first thing you always do that sometimes we forget about? The GCF. Does this have a GCF that we can factor out? Yes or no? Yeah, what is it? 25. All right, I'm going to show you 2 different ways to do this problem. Here we go. Number 1, GCF. So we go 25 times x squared minus 4. Right on? Right on? Y'all got to give me a grunt or something. Come on now. There we go. Now what do? Now it's a difference of squares. Bring down your 25. X minus 2. X plus 2. Done. Right? Y'all cool with that? Okay. Did anybody go this way? And I do want you to write both of these ways down on your paper. What's the other way you could go? Still going to get the same answer. Going to approach it a different way. All right. Go difference of squares all the way, right? All right, here we go. Difference of squares, which is what I think you were saying, Jansen. Kayla, you said 5x, 5x, 10 and 10, plus and minus, right? Now, this is when you ought to hear, woo, 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 woo. What do we have to do now? You can't ignore it. Now you got to take out a 5 from both quantities, right? Because isn't the GCF of 5x plus 10 5? So 5 times x plus 2, right? And then don't I have to do the same thing over here with 5x minus 10, yes or no? Take out a 5 times the quantity, x minus 2. I wish y'all could all have color pencils at your desks. I wish your desks had little holders, you know, like the bicycles with the baskets. I wish y'all all had baskets on your desks with pencils, like color pencils and markers, because y'all see how I use my colors. Now, am I done with that? Damien, what will I do at this point? Multiply my 5s together. 5 times 5 is 25. Well, I will be John Brown. Look at her here. Look at her. They're the same thing. But we approached them differently. Is that okay? Miss Perry, are you going to count it wrong if I do it my way? What's the answer? No, as long as you do what? Well, because some of us may, all right, let's think about this. As long as you get, but I did it a different way, Miss Perry. Here's the answer, see? Boom. And I could have gotten Cody's paper and copied his work. Except I just did it. Oh, my work is I don't know where I put my work. I'm going to tell you right now, do not do that to yourself and don't do it to me. My mama did not raise no fool. And if you are somebody that you do your work like you're supposed to, and you let somebody copy your work, you're crazy. You're crazier than one. You're sorrier than the one copying your paper, because you are wonderful, and I love you. Sum and difference of cubes. You know, it's that pattern. There is a okay. Sum of cubes. Let's look at the sum first. This is horrible, horrible, horrible. Look. What the world? That was my fault. That was my fault. Okay. This has a crooked problem. I don't know what it is. Here we go. Let's look at this one. If I were to give you x cubed plus 8, do you remember the pattern that you have to follow? I hope you do. Remember, when we have a sum or difference of cubes, remember it's a binomial times a trinomial. All right, the binomial and the trinomial. Here we go. What is the cube root of x cubed? Everybody. X. What is the cube root of 8? Everybody. 2. Now, how do we get the first term? Here we go. X, this term squared is what? X squared. You may want to watch this if you need to refresh your memory. This term squared is what? 4. It goes at the end. How do I get the middle term? X times 2 is 2x. And then what about the sign pattern? Here we go. If it is the sum, that means addition, right? So it's plus, minus, plus. Folks, it ain't nothing you can do but just flat memorize it. That's all you can do, okay? And I'll show you how I memorize it. If y'all wouldn't have said it, I would have forgotten it. I have to go the other way. You'll see. Here's the sum of, not sum, difference. Difference of cubes. What time? 11:50. All right, we got. Let's go with 8x cubed minus 125. All right, you ready for this? Same thing. Binomial times a trinomial. Ready? What's the cube root of 8x cubed? 2x. What's the cube root of 125? 5. 5 times 5 is 25, times 5 is 125. Now, this is why I say it this way. This term squared is what? 4x squared. Good. This term squared is what? 25. What's my middle term? 10x how? 2x times 5 is 10x. Y'all with me or no? Because I'm seeing some blank stares. Or maybe you're just processing, okay? And if my eyes land on you, it doesn't mean that I think you're lost. I'm just trying to make eye contact with everybody in here so you don't feel like you're just in a room of 35. Okay? All the signs on this one. Here's how I remember it. Okay? Because I don't like memorizing stuff. I have a hard time memorizing. Look at the word subtract. And I purposefully write my T's that way. What do my T's look like? Plus signs. So if I have a subtraction problem, oh look, the sign's in the name. I discovered that. Isn't that the coolest thing? I just remember that one, and I know the other one's plus, minus, plus. But this is my go-to one all the time. And if you were to ever see my key when I grade the factoring unit, all subtract, I have to write the word out so I can then write under it minus, plus, plus every single time. Because there's no reason to memorize. Patty, how we doing? Do you remember this? How many of you are like, bring it on, bring it, bring it? Y'all cool? Great. I love that. You're so eager to learn, folks. Your enthusiasm. Stop it. Shh. You're too loud. Here we go. See, now when I sit down, I do not have a but. I do have a but. I have plenty of but. I do not have a button that, like, when I sit in my chair, automatically y'all learn how to talk again. I don't understand that. Talk to me. You want to punish me? You're punishing me right now by not talking to me. Easter, I see you plotting, grinning, that sinister with your mustache, twisting the corners. All right, factoring trinomials, folks, unfoiling. Yeah, don't be ugly to me and not talk. I want you to talk when you need to talk, and then shh when you need to shh. You need to talk. Here we go. Remember unfoiling, a squared plus a minus 42. Am I going too fast, or y'all all right? All right? Okay. What do we do? It's a trinomial, so you know it's going to bust down into two binomial factors. What's going to go in my first spots? A and A. And then this is the way I go about every single one of these problems. What are the factors? And you got to watch this, folks. Okay? Especially if it's been a while since you factored. What are the two factors of 42 that when you subtract give you 1? Somebody's saying it. 6 and 7. All right, now, before I throw my signs in, I look at this and I go, hey, does that mean same or different signs? Different. Which one's going to get the plus? The highest, which is the 7, right on? That's the way I do every one of those problems. And you may have learned it differently. That's fine. But you're going to hear me say the same thing over and over again. Y'all remember unfoiling? That's so easy. We also want a quiz full of these too. Here's another one. Oh, let's do this here. What's going to happen when we have a leading coefficient other than 1? 2a squared plus 5a plus 3. Remember yesterday, I told you that I tend to do this. Some of you are going to go trial and error, and that's fine. I'm going to do slide and divide. I have found for me, it is a process, and if I do the same process, I get really, really, really good at it. I don't want to have to work 400 combinations of numbers to make it work out, okay? Again, I don't care which way you solve this, which way you factor this, but I'm going to show you slide and divide, okay? So write this down. It would do you well just to have another tool in your toolbox to use in your math toolbox, okay? Here we go. Slide and divide. I'm going to take the leading coefficient 2, and I'm going to multiply it to 3. And folks, you're going to see me tie them together like that every time. And I'm going to rewrite, bless you if that was a sneeze, I'm not sure it was. All right, a squared, I'm going to bring that down, plus 5a, plus 2 times 3, which is 6. Oh, now I can factor that all day long. Here we go. A and A. What are the 2 factors of 6 that when I add give me 5? 2 and 3, right? My signs are the same. They're both going to be pluses. Now here's the part, if you're not conscientious, everybody forgets. And I want you to do this. Come here and draw you an arrow just like that. What do I have to do with the 2 now, folks? I have to bring it down and I have to divide it into both of those numbers, okay? We either have to reduce or rewrite the factor. What is she talking about? We either have to reduce, what's 2 divided by 2? 1. Or we have to rewrite. How will I rewrite a plus 3 over 2? Say it, Kelly. 2a plus 3. All I did was I took that denominator, I made it the coefficient of that first term, and then I wrote it as plus that numerator. Folks, there is some algorithm out there that somebody realized if you did slide and divide, if you do slide and divide like this every time, it'll work every single time. Do not ask me what that algorithm is. I do not know, and I do not care. I know how to factor. That's all that matters. Okay, fair enough? How many of you have seen slide and divide before? I know my little children's have. Okay. Some of you like it, some of you don't. Some of you tear it up with careless mistakes, and I just want to go. You don't have to. You don't have to do it this way, though. If you want to go trial and error, you go trial and error all day long. Do you do the chart? You just do trial and error. Thinking it's all good. Do it. I don't care. Okay? How many of you, out of curiosity, go trial and error, no matter what? It's all good. Keep doing it. It's keeping your brain quick. I got to just do the process. It's got to be a no-brainer for me. This is a no-brainer for me. Questions? Y'all cool with this? Awesome. God, y'all are so loud. Shut up. Holy crap. Here we go. Do this one. 10 seconds. Go. 10, 9, 15, 8, 7. It's probably going to be about 20. I forgot my number. 6. Hurry. 5. 4. You better be done. 3. I stretched that out to 30 seconds for you. 2, 1. Easy to factor, yes or no? Yep. Is it factorable? Yep. X and X. 2 factors of 15 that when you subtract give you 2. 3 and 5, are you signed same or different? Different. Which one gets minus? 5, right on. How many of you got that right there? High five in the air. Bam. Atta boy, atta girl. Atta class. Questions at all? Facile? Good. Facile. Is that it? Christian? I don't know. He's not paying attention. Look at this jacked up writing, y'all. That's not how I write. It is like, oh, grouping. Oh, grouping. Oh, I hate grouping. But we will tolerate it. When do we group, y'all? 4 terms. 4 terms. Maria, it's like a gang symbol. Gang signs. Don't be throwing up gang signs to me in the hallway. We'll get in trouble. Here we go. 4 terms almost always have 4 terms. Sometimes, remember, we are in an advanced math class, but it could have quantities thrown in there, and then you think, oh my gee, what in the world? Okay? Check this out. 10ax minus 2xy minus 15ab plus 3by. I love to group. Grouping is fun, and it's awesome. Wonderful. It is a B before the Y, yes. I'm not offended that you can't read my hand, that you can't write my reading, that you can't read my writing. Sorry. It is kind of crappy. I can't help it. What do I do? You remember how to group? We go over it for like 5 seconds in Algebra 1 because none of us like that. Okay? Take the first 2, factor out the GCF. Okay? What's the GCF of 10ax minus 2xy? 2x, right? See, I didn't write my 2 that way. 2x times what? 5a minus who? Plain old y, right? All right. Now the next one. What's the GCF of 15AB and 3BY? 3B. All right, here we go. This is the one I always have to think about. Is that going to be a minus or a plus there? And I always have to think about it. Well, I need this other quantity to be 5A minus Y, right? Okay, if you remember from Algebra 1, maybe Algebra 2. Negative 3B times what gives me negative 15AB? Positive 5A. Whew. Okay, good. It works. Negative 3B times what gives you positive 3BY? Negative Y. Thank you. Do my quantities match? Yes. Now, folks, you're factoring out another GCF because that's what this really is. It's just another GCF. And what do we do with GCFs? Greatest common factors. We throw them where? To the front. So we're going to throw that GCF to the front. And what's left over? 2x minus 3b. And we're done. Hey, how could you be sure that I'm not telling you a bunch of lies with this? Pull them back out, right? Could you feasibly know your grade before you turned in a factoring quiz or test? Yeah, it might take you 3 days to do it. But you could rework all of them, and as long as you go back to this right here, you're good to go, aren't you? Yes or no? Folks, I cannot tell. Do you understand that? You can factor this, multiply this. Great. Okay. Good. Good, good, good. Grouping. Here's another one. Actually, this is number 52. You'll see what I'm talking about in a minute. A squared minus 1, the quantity, times b squared minus 4 times the quantity a squared minus 1. Anybody have any ideas? What you think? Say it again. Oh, like a quantity. So the quantity is a GCF, huh? Yeah? So you're saying factor it out? Okay. That's what I thought. There we go. What are we left with? What are we left with, y'all? Come on. B squared minus 4. And now what? Are we done? Done. Circle it. Done. No, why not? What do we have? 2 differences of squares. Here we go. A minus 1. A plus 1, yes? B minus 2. B plus 2. Any way to clean that up? Or is that about as clean as it can get? That's about all we can do with that. Right on? Question? Hold up. Say it again. Yeah. Yeah. What would you have? Would you pull the a squared minus 1 out as a GCF, though? Would you still have done that? Okay. Yeah. So you actually just went straight to this and this? All right. Dan, did you click? You bust that? All right, yeah, you're fine. Questions at all? All right. Here's what you're going to do, and you're going to get started on it before you go. No moaning, no groaning. Y'all got this. You got 3 days. Put your big girl panties on and deal. Let me see if I can write that. Okay, do y'all see that? It's not me doing that. There is like a shaky spot. Oh, that was better. I want you to do 27 through 51, 53 through 57, and 59 and 60. Folks, I'm going to tell you right now, 57 through the end might make some of you cry. I'm just telling you. It's not, you're not on a bottle anymore, folks. Okay? You're on solid food. You got this. Get on it now. And is it all or odd or even? It's all. Do all. Okay? Get on it now. All it is all of the factoring thrown in there together. And what are you going to bring me Monday? Pink sheet, signed and initialed. Signed and initialed. You all right? Where's your book? Why?